Here's a question from Physics on Ramps from UT, and I got this wrong. It's about waves moving in tubes. I did this wrong earlier today because I botched the resonances and harmonics. Here's a discussion of resonance and harmonics to make sure this is done right. Here are the resonances. 1, 2, 3, 4, 5, 6, 7, 8. That's as far as I'll go. And then there's two types of systems. Open, where both ends of the tube are open, and open closed, where one end is open, one end is closed. When one end is open and one end is closed, the harmonics are only odd numbers. When they're both open, they can be even numbers. So the first resonance in an open is one harmonic. In an open closed, one harmonic. Now they get different. In the second resonance in an open is two harmonics. In an open closed is three. See how it's getting different? The third resonance, here is 3 for open, then it's 5. 4, 7, 5, 9, 6, 11, 7, 13. So in an open, the resonance and a harmonic, same number. In an open closed, the resonance has to be multiplied by 2 and then 1 subtracted to get the harmonic. 15. So that gives it two different formulas. The length of the tube, this is in an open versus an open closed. I'll put the L over here. Length equals N times the wavelength divided by 2. And in an open closed, the length equals 2N minus 1 times the wavelength divided by 4. You can look on YouTube to find a discussion of the reason for the 2 for an open and the 4 for an open closed. But anyway, this is an open closed, so this is the formula that's going to be used. And that N is the resonance. So for the 7th resonance, 2 times 7 is 14 minus 1 comes out to 13. The third harmonic is 13. And that's what multiplies by lambda there, the wavelength. All right, so the question says an open vertical tube has water in it. A tuning fork vibrates over the mouth. It's vibrating over the mouth. As the water level is lowered in the tube, the 7th resonance. 7th resonance, 13 harmonic for an open closed. This is open closed because the top is open, but the water blocks it at the bottom. So it's closed there. So it's open, closed. As the water level is lowered in the tube, the 7th resonance is heard when the water level is 191.75 centimeters below the top of the tube. What is the wavelength of the sound wave? All right, so I'm going to manipulate this formula to find wavelength, and I'm using open closed. To find wavelength, I multiply both sides by 4, 4L, divide both sides by 2N minus 1, and that's going to be the wavelength of the nth resonance. And in this case, I want the 7th resonance. So what is wavelength? 4 times the length. 4 times, what is the length? 191.71. 0.75 rather. Centimeters divided by 2N. 2 times 7 minus 1. And 4 times 191.75 divided by 13, in other words. And that comes out to 59 centimeters. I'll show you that on Desmos. What was it again? 4 times 191.75 divided by 13. 2 times 7 is 14, minus 1 is 13. 59 centimeters. So I've got the first part. That is question 19. Question 20 is part 2. What is the frequency of the sound wave in the tuning fork? Answer in units of seconds minus 1. In other words, 1 over seconds. Well, I've got the wavelength is 59. I've got the speed of sound, a speed of 59 centimeters is the wavelength. I've got the speed of sound as 343 meters per second. Well, if I divide meters per second by centimeters, I'm going to get meters per second centimeters. If I divide meters per second by meters, the meters will cancel out and I'll have 1 over seconds. So I have to convert this wavelength into centimeters, or into meters rather. Now here's, remember this one has a triangle, velocity, frequency, wavelength. So frequency equals velocity divided by wavelength. Maybe I already said that. Frequency equals, and I've got to turn the wavelength into meters, divide 59 by 100. Velocity, 343. Wavelength, 59 divided by 100 is 0.59. And that's going to equal 343 divided by 0.59 equals 581.36 approximately. I had to round it. 581.36 seconds to the minus 1 power, or hertz, whichever one you want. This one asks for seconds to the minus 1 power, 1 over seconds. Now the final question here. The water continues to leak out the bottom of the tube when the tube next resonates. Well, that was the 7th resonance, so this is going to be the 8th resonance. 2 times 8 is 16, minus 1 is 15. There's your harmonic is 15. So the length is going to be equal to 2n minus 1, 2 times 8 minus 1 times the wavelength. Now this time it wants it in centimeters, so I can just put 59 centimeters for the wavelength divided by 4, which is equal to 15 times 59 divided by 4, which is equal to bam, 221.25, 221.25, and that's centimeters. So there's all the answers. For question number 19, it came out to 59 centimeters. For question number 20, 581.36 seconds to the minus 1, approximately. And for question 21, 221.25, and that's exact. Nothing to cut off, no other decimals there. 221.25 centimeters.